Hello, we are in Chapter 6, Exponential and Logarithmic Functions, and we're talking about Section 6.3, Logarithmic Functions. In this section, we will convert from logarithmic to exponential form, convert from exponential to logarithmic form, evaluate logarithms, use common logarithms, and use natural logarithms. So let's first talk about what a logarithm is. What in the world is a logarithm? Well, let me just kind of come down here first before we look at that slide. Okay. A logarithm is an exponent. That's it. That's all it is. People see the word logarithm, they get a little freaked out over it because they think it's super hard. It doesn't have to be hard because all it is an exponent. Let me show you. So let's say we have something that you've seen before, such as 9 squared equals 81. Okay, this is a problem with an exponent in it. Hopefully you're familiar with what that exponent means. It means 9 squared is 81. We would say 9 squared is the same as 9 times 9. 9 times 9 is 81, and that's how you would get that answer. Now, the pieces of this exponential form, we have a base, which is 9, carried to an exponent, and that equals an answer. And that's usually how we're used to seeing things up to this point. We have a base, an exponent, equals an answer. Now, when we do a logarithm, you're going to have the same three numbers that you saw here. The 9 squared equals 81. We have the numbers 9, 2, and 81. You're going to have those same values in a logarithm problem. Okay, just remember the logarithm equals the exponent. So if I'm finding the logarithm here, the answer is going to be 2 because 2 is the exponent. So let me just show you how we would write this. We start off by writing the word log, and then as a subscript, you're going to write the same number that was the base in the problem on the left. That number is going to be your base of the logarithm, except you write it as a subscript to the right of the word log. Then the number on the left that was the original answer, that's the number that goes here. It is not written as a subscript. It's written the same size as the word log. Okay, and then that equals our answer. And in this case, the answer is not what the answer used to be. The answer is now the exponent. So log base answer equals exponent. So let's write it up here. We have log. The base on the left was 9, so the base on the right will also be 9. The answer on the left was 81, so that would be what we would write here. And this is read log base 9 of 81. Okay. So, log base 9 of 81, what we're asking is 9 to what power is 81? So we would be saying to ourselves, 9 to what power is 81? That's what you're going to ask yourself. And 9 to what power is 81? We already know because we can see it on the left-hand side. 9 squared is 81. So log base 9 of 81 equals 2 because 9 squared equals 81. That's all a logarithm is. It's just finding the exponent. That's all it is. So let's look at a couple before we go back up to that earlier slide. So let me see so you can see this part. So if I said log base 3 of 9. We'll do log base 5 of 125. We'll do log base 2 of 32. And maybe we'll do log base 6 of 1. Yeah, okay, let's just do these. Okay, so let's think about what these mean, all right? This first one, remember, we're looking for the exponent. The base is 3, so we're saying 3 to what power equals 9? So 3 to what power equals 9? 2, because 3 squared equals 9. All right, let's look at this next one. Log base 5 of 125. So 5 to what power is 125? That would be, think about it. Did you say 3? It is 3 because 5 to the third equals 125. 5 times 5 is 25, times 5 is 125. All right, let's do another one. Let's do log base 2 of 32. So we're asking ourselves 2 to what power equals 32? You might have to think about this one for a minute. Did you say 5? Because 2 to the 5th is 32. One more, log base 6 of 1. So we're saying 6 to what power equals 1? This one you really might need to think about. Did you say 0? Because 6 to the 0 equals 1. Anything to the 0 power is 1. So that is basically what logarithms are. They are exponents. So let's go back up to this first slide where they kind of explained to us what logarithms are. So a logarithm, base b, of a positive number x satisfies the following definition. For x is greater than 0, b is greater than 0, and b doesn't equal 1. Y equals log base b of x is equivalent to b to the y equals x. So on the left in the log problem, look where the x is, and look where it is over here. Look where the y is in each equation. So you can see that the answer y is the exponent in the exponential form of the equation, and x is the answer of the exponential form equation, but it is part of the problem in the logarithmic form. So you can kind of see how those are switching places, where in one x is the answer and the other y is the answer. So this just talks about how we read the logarithm log base b of x. Now, look at this next paragraph. Since logarithmic and exponential functions switch the x and y, as I just showed you, the domain and range of exponential functions are interchanged for logarithmic functions. So if you remember, for exponential functions, the domain was all real numbers. Well, now look here at, for the log function, the range is now all real numbers. So it's the opposite. It's switching it. And then if you will remember, the range for exponential functions was 0 to infinity. And check this out. That is now the domain for log functions. Okay? So let's go down to converting from logarithmic to exponential form. So sometimes they're going to give you an equation in log form, and you're going to be asked to convert it to exponential form and vice versa. So basically what you need to do is you need to identify the base and the exponent and what would be the answer, and then rewrite it in the correct format. They kind of give you a little model to follow here. So it says write the following logarithmic equations in exponential form. I'm going to do the first try it with you, and then I'm going to let you guys do the second try it on your own, and then we'll come back and see what the answers are. So for the first one, log base 10 of a million equals 6. So in this case, we identify the base, which is 10. The exponent is the answer, which is 6. 10 to the 6th power is a million. And that's all there is to it. Look at B. Identify the base. The base is 5. The exponent is the answer, which is 2. And that leaves 25. And you can always go back and check these numbers. If they're numbers and not variables, you can check and make sure that it's accurate. 5 squared is 25. 10 to the 6 is 1 million. So pause the video and you guys try the second try it, A, B, and C, and then unpause when you're ready to go over the answers. Oh, by the way, they're asking you to go backwards, so you're going from exponential to log form, whereas up here I was going from log to exponential form. Okay, so pause the video and then come back when you're ready. Okay, so for the first one we have log base 3 of 9 equals the exponent. For the next one, don't want it all to be smushed. I'm going to kind of put it further to the right. We have log base 5. Remember, logs equal the exponent, so the 3 is going to go there because it's going to equal 3. That means the 125 goes here. So log base 5 of 125 equals 3. This one, oops, it looks like they cut off the answer. The answer here was 1/2. All right, so let's write this as a log. Log base 2, I'm going to leave a space, equals the exponent. What is the exponent? The exponent is -1. That means the 1/2 goes here. So log base 2 of 1/2 equals -1. All right, great job. So I'm going to give you guys a few to try. So I'm going to write it in one format. You convert it to the opposite format. So if it's a log, convert it to exponential form. If it's exponential form, convert it to log form. And I'm mixing it up. I'm even putting in some variables to see how you do with that. All right, so why don't you try these four? For the first two, convert those to exponential form, and for the last two, convert them to log form. And unpause when you're ready to check your answer. All right, so checking our answers for the first one, we're converting it to from log form to exponential form. So the base would be 3. The answer of log base 3 of 81 equals 4. The 4 is the exponent. That means it equals 81. You can check 3 to the 4th does equal 81. So we're going from log to exponent again for the next one, except this one we're using all variables. So the base variable is A. The exponent is what the log equals. So that's C equals, the number that's left is B. So just remember, each of these only has 3 numbers. You just need to make sure you know where each number goes, and you're good. So now we're going to convert it from exponential form to log form. So we start off with the word log. We've got your base, which is 4, of some number equals the exponent. The exponent is 3. That means 64 goes here. Last one, exponential to log form. We've got log base b of some number equals the exponent, which is d. That means e goes there. Okay? Alright, so we're going to pause here. We're going to stop the video here, and then we're going to pick back up with part 2 in the next video.